This is a presentation of my summer research project called Understanding Changes in the North American Monsoon Precipitation in CMIP6 Climate Models. The North American monsoon is a weather system that dominates Mexico and the southern US. You can see from this map that there's a lot of precipitation in the west coast of Mexico. During the July and August months, a low pressure develops over the area, sucking in moisture from the oceans and creating a lot of thunderstorms in the area. So I choose to study the precipitation in this region right here to represent the monsoon system as a whole. This graph shows the precipitation cycle of the area. You can see that there's a lot of precipitation from June to September. I choose to study this with the Cultural Model Intercomparison Project Phase 6, which I will call CMIP6. It is a collection of the most cutting-edge climate models that just came out this year. I then use all these models to plot the precipitation cycle of the area. And here's the summary. The black curve shows the real-world observations, while the blue curve shows the multi-model mean. It turns out, CMIP6 models tend to overestimate precipitation during the winter, and also, there's a lot of disagreement between models. Just look at the error bar. So, if climate models cannot accurately portray the monsoon, then we cannot trust the future projections of the monsoon, which means we cannot prepare for climate change. My question here is, what makes a climate model perform better than another at portraying the North American monsoon? My hypothesis here is that less sea surface temperature bias in a model makes the model precipitation more accurate. Let's define what this means. A climate model is comprised of an atmospheric model and an oceanic model, but since they are just models, when we run them, the oceanic model will get the sea surface temperature or SST slightly wrong compared to the observations. On the left map we have the observations, on the right map we have one of the models. You can see that the model overestimates the surface temperature over the Gulf of California. The sea surface temperature bias or SST bias is the difference between the observed SST and the model SST. So the way to make SST biases the independent variable, I use the two types of climate models, the coupled model and the uncoupled model. In the coupled model, the atmospheric realm and the oceanic realm are allowed to communicate with each other, hence coupled. However, for the uncoupled models, instead of using an ocean model, we use real-world sea surface temperature observations as the boundary conditions for the atmospheric realm instead. This means that the coupled models have sea surface temperature biases, whereas the uncoupled model have no sea surface temperature biases by definition. Plot them out and get this. The black is observations, the blue is the coupled models, and the green is the uncoupled models. The green is much closer to the black compared to the blue, which means that the sea surface temperature bias have a significant effect on the accuracy of the model. Now let's look closer. In this plot, each dot represents a climate model. The x and y axes are statistics that represent how accurate the models are. The x-axis is the error, the y-axis is the correlation. There's a lot of green dots towards the top left compared to the blue, which means the uncoupled models are more accurate in general. Moreover, I use another statistical test to support this claim. On the left map here, we have the observed precipitation. On the right map, we have one of the model's precipitation. The spatial correlation measures how correlated these two maps are, so the higher the spatial correlation, the better the model. And from this plot, you can clearly see that the uncoupled model is better because it is higher in spatial correlation and it is more consistent. And finally, for this plot, I computed the average amount of sea surface temperature bias each model possesses and plotted against the correlation of each model. As you can see, there's a weak correlation between the two factors, which means the higher the bias, the worse the model, which supports my claim a little. Now, just for fun, I would like to see how will the monsoon respond to global warming. So, I choose 5 different scenarios to replicate global warming. For example, the bottom one here is when I quadruple carbon dioxide in the atmosphere. As you can see, in 4 out of 5 scenarios, most climate models predict a decrease in monsoon precipitation, which means that the monsoon might be weakening because of global warming. To sum it up, if you want to study the monsoon system with climate models, you have to choose ones that have low sea surface temperature bias. And also, the North American monsoon is most likely weakening due to global warming, which might mean less rainfall to Mexico and the southern US. That pretty much sums up my research project, so thank you.